we are going to use mathematical induction to prove that for every positive integer n, 11 to the power of n minus 1 is divisible by 10. Okay, so first off, we'll start with the base case. So the base case is then going to be for n equal to 1, because that is the first positive integer. Okay, so 11 to the power of 1 minus 1 is equal to 10, which is obviously divisible by 10, because it is itself. So, therefore, it is true for the base case, or for n equals to 1. Okay, now we use the inductive hypothesis. And for this, we assume it to be true for n equals to k. So what we're saying is 11 to the power of k, because we're substituting in k for n, minus 1 is equal to 10 times by some natural number p. So we say p is an element of natural numbers. The reason why p must be an element of natural numbers is because if our base case has n equals to 1, then it turns out that 11 to the power of 1 minus 1 is 10. So everything greater than that will yield answers that may be divided by integer values that are greater than 1, because 10 divided by 10 is 1. Okay, so that's why we have p must be an element of natural numbers. So this is basically just saying that this is divisible by 10, because it gives us a whole number. Okay, so then we move along to the inductive step. So now we must prove it to be true, our statement to be true, for n is equal to k plus 1. Okay, so here's where the manipulation comes in. We substitute in k plus 1 for n. So we have 11 to the power of k plus 1 minus 1 is equal to 10 times by some number r. And now we need to prove that this number r is also an element of natural numbers. And if it is an element of natural numbers, or it is a whole number, then we can say that this is in fact divisible by 10. Okay, so now what we do is for this 11 to the power of k plus 1, we can split it into 11 to the power of k times by 11. So then, of course, that's still minus 1 is equal to 10r. All right. Now what we do is we take this negative 1 across. So we add 1 there. Now we divide through by 11. Now what we need to do at this point is we need to try and relate this, to our inductive hypothesis. Because we are doing the inductive step on the premise that our inductive hypothesis is true. So if we then prove our inductive step to be true, or n is equal to k plus 1 to be true, then we can validate our assumption in our inductive hypothesis. So we have to somehow relate our inductive step to our inductive hypothesis. Okay, so in order to do that, we're going to subtract 1 to make these left-hand sides the same. So of course, if we're subtracting from the left, we have to subtract from the right. Now, for continuity and to make everything seem similar on this right-hand side, we're going to instead have every term with the denominator of 11. So minus 1 is the same as negative 11 over 11. Okay, so then 1 over 11 minus 11 over 11 is the same as negative 10 over 11. All right. Now, we said that 11k minus 1 was equal to 10p, with p being a natural number. So we can substitute that in over here. So we have 10p. Okay. So now we can take out, or we can have our common denominator over here being 11. So that's 10r minus 10 over 11. Okay. And I take that 11 across, I multiply through by 11 now. And then I get 110p is equal to 10r minus 10. And now what I do is I divide through by 10 for every term. So I get 11p is equal to r minus 1. Okay, so now r must then equal to 11p minus 1. And now this is a crucial moment, because we know that p is in fact an element of natural numbers. So if p is an element of natural numbers, and we multiply it by another natural number, 11, and then subtract 1, our r is also going to be an element of natural numbers. And it is at this point that we can therefore state that it is true for n is equal to k plus 1. And when I say it's true for n is equal to k plus 1, I can say that 11 to the power of k plus 1 minus 1 is divisible by 10, because r over here in this expression is a natural number. So we therefore say that the initial statement, and then obviously if you're in a test environment, it's wise to write out, you say, for every positive integer n, 11 to the power of n minus 1 is divisible by 10 by principle of mathematical induction. But since this is a video and I don't want to waste your time, I'm just going to abbreviate it to by principle of mathematical induction. And that proves it to be true. Thank you.